afternoon from Mountain View, California, the SETI Institute. My name is Bill Diamond, CEO here, and we're going to be going to Mars today. But before we go to Mars, if some of you were watching last week, we had a couple of very cool episodes where I was down at Palmdale in Southern California at the NASA Armstrong Air Base, where this guy, maybe Lee, we can zoom in on our friend Sophia, is based. And I had the great fortune to accompany our teachers who are part of the Airborne Astronomy Ambassadors program. It's a program we run for NASA, which is all about promoting STEM in our school systems and giving science teachers in our high schools, particularly high schools that don't necessarily have the budget or the programs for major STEM activities, but we were with a brilliant set of high school teachers, mostly teaching physics and chemistry and astronomy and so on, and giving them the opportunity to get on this plane and see infrared astronomy being done by scientists, see science being done in the field, and bring that experience back to their school districts and get more kids excited about STEM. So we should have some hearts and thumbs up for STEM, because I think we can all agree that a scientifically literate voter population is a pretty important thing to have these days. So let's hear it for Sophia and STEM and for our Airborne Astronomy Ambassadors program. Anyway, awesome experience. We're going to be doing some storytelling on the website with pictures from inside the plane. You can see the telescope and the telescope operators, the scientists, the teachers, and how the plane's laid out. Pretty amazing, wonderful experience. And so check out our Facebook page and go back and look at those two from last week. Lots of fun. But today we're going to Mars. One of our scientists, J.R. Scope, is a bit of an entrepreneur. Like many of our scientists, they have their own kind of activities and programs that they're working on the side. And J.R. has been involved in a very creative program that he's come up with, which is all about how in the future, when we are established on Mars and have a presence there, we're going to be relying on the resources available to us on Mars to make things, to make products, to build habitats, to fuel rockets, to feed and water plants and our human inhabitants of Mars, etc. So he has an enterprise that he started called Made of Mars, where he's actually engaged in using raw materials that we know are available and in fact plentiful on Mars to make products that you can actually buy here and now, to give you an idea of what's involved in using available resources to make things that can be helpful and handy. And he's got actually a fundraising campaign going on now to help get his idea off the ground. So this is really about supporting our scientists. This is not a program of the SETI Institute, but it's a project of one of our scientists. We like to support the entrepreneurs that we have, and of course, the work that he's doing is right in our wheelhouse in terms of Mars exploration. So let's go meet JR, and in the meantime, if you're with us today, tell your friends and let us know, push it out. I'd love to have a big audience today. Let us know where you're watching from. We had some people from Scotland, England, Portugal, Tunisia, Philly, Pittsburgh, Texas, lots of folks watching us last week, which was a lot of fun. So let us know where you're watching from, and as we talk to JR, how you doing? Good to see you. As we hear more from JR, let us know your questions. Rebecca's here writing things down, so we'll give you an opportunity to ask questions and jump in. So anyway, JR, thanks for coming, and I know you've got a lot of cool stuff to share. So, and I told folks kind of roughly, what this is about. This is about using available resources ultimately on Mars to help support habitat there, etc. And you're starting that process right now, starting to help us learn what those things are, those challenges are all going to be like. So let me turn it over to you and have you tell us more about Made of Mars.
Yeah, Made of Mars, as Bill said, is trying to build the infrastructure that we need when we get off Earth. Once we leave Earth, we won't have all the wood and the metal and the plastics and all the things that we are used to building here. So we'll have to build what's on Mars if we go there, on the moon, or asteroids throughout the solar system. And that's what my career has been, is figuring out what is out there. I've mapped the surface of Mars with satellites, with rovers. I've worked in analogs, places that look just like the moon, like Mars, traveled the world to understand what are these materials like. And we won't have any of those other things, wood, plastics, any of that. But
at least for a while.
But right now there's volcanoes.
Yeah.
So I brought some volcanic rocks. This one came from a volcano I did some work with in Southern
Zoom
California.
in on that one, Lee.
So this is just a volcanic flow. If you've seen the amazing photos of Hawaii erupting, this is just a piece of a lobe that would have crystallized out of that volcano.
So you see it kind of flow and cool and flow and cool, and you get these, like, it almost looks like it stacks up.
Yeah, so this rock
Cool.
is incredibly common on Earth. It makes up Hawaii and Iceland, makes up the ocean floor. Every continent has some of it somewhere as the Earth's gone through geological eruptions and volcanic emplacements. But it's also common throughout our solar system.
And what is the material, the raw material?
So this is
mostly?
basalt.
It's
So this
basalt.
is silica, iron, magnesium, basalt.
Mhm.
So it's a volcanic basalt, common on Earth, but it's also incredibly common on Mars. In fact, most of Mars is basalt. There are some places like the big Olympus Mons and Sirius Major, which are almost entirely nothing but basalt. But even the rest of Mars is mostly basalt. Even places where we have clays and alteration, it's still mostly basalt with a good percentage of clays mixed into it.
Mhm.
So basalt's one of the most common materials that we know we have on Mars. It's also found throughout the solar system, even the near side of the moon, the mare of the moon. All the dark parts when you look up at the sky and see the moon is made of the same kind of volcanic basaltic rock. It's also in asteroids, like 17–18% of all asteroids that we've mapped.
So it's
mostly
indicative
basalt.
in the case of the moon of past volcanic activity, right?
Yep.
Which a lot of people don't necessarily realize. We think of the moon as this, stationary, non-dynamic system, just a rock spinning around Earth, actually not spinning, going around in an orbitally, tidally locked orbit around Earth. But it has a dynamic past. It has water on it, we know now.
3 billion years
and
ago, it was erupting.
erupting volcanoes, and yeah, interesting.
So this material is incredibly common. So this is where I'm kind of want to start this process for. And so we can take this rock and melt it back down to lava, and we have the processes to pull this lava into threads.
Mhm.
Like if you go to Hawaii now and see the big fire fountain eruptions there, this kind of happens naturally. It's called Pele's hair. So you can find deposits where there's very fine-grained glass threads just form naturally, and that's
okay.
a very natural process. So what we figured out how to do, now this has been known for a while now, is how to take this back to the lava and pull it into very fine threads. So that's what this is. This is just pure volcanic rock that's pulled together. You can feel how soft it is. It's
Yeah,
like
I mean,
almost
it feels like silk
baby's hair.
almost.
Yes.
Yeah, it's amazing.
So,
And does it have good tensile strength?
it's pretty strong. It's
What's the size of this? It's almost like human hairs. It's like
Yeah.
80 micron.
Yeah,
100
something.
micron?
It's definitely. It's pretty thin. It's not thin enough to be hazardous to the health. So that's
Yeah,
that's
yeah.
good.
Mhm.
But it's pretty thin, and depending on how you want to weave it, you can weave all sorts of fabrics. So this here is one type of
Bring it
fabric.
up and show
You can
the,
show one. So this just shows one type of weave, and this is used for like wrapping up like pipes and other sort of things where you want to have like wrappings of it.
This could be like also strapping for lifting,
Yeah.
hoisting material.
and ropes too.
Yeah.
Like whatever you can imagine that threads can be is what basalt's already being used for.
And again, the texture here, Lee's curious. Lee, check it out. It's very soft. It's and very shiny, as you can see. And the way this one is woven, of course, it has the ability to spread and stretch. Is tell us where this color comes from. It has this kind of interesting goldish, copperish kind of hue.
So basalt, like most rocks, it's when you melt it down, it becomes a bit of a glass. So it's the iron magnesium of basalt that gives it this light color.
Mhm.
So the mostly silica content, it's like almost 50% silica, just like what glass is entirely. So that wants to be 50% clear, and then there's a bit of iron magnesium atoms in there that give it this
Give it a little bit
particular
of
color.
Yeah.
Yeah, so that's like right now it's used a lot in industrial purposes. So typically they don't care about the color.
Right.
But if we go to Mars, maybe we want to have some color in our life when it's all red outside all the time.
Yeah.
And this is the only material we have. Learning how to create more colors that people use for different purposes is some of the research that we're trying to do. Figure out
So
how
we
to
don't
make
yet
this.
know how to change the color
Not
of
yet.
this.
That's still something that has never been.
Because it's not really, it's not like a conventional thread that will absorb a dye.
Yeah, you can't dye it. You have to
You have to apply a color.
Yeah, think of more like stained glass. Where stained glass, you take clear glass, you add certain chemical compounds, that
Okay.
creates the colors that you want.
So it might
this-
be like a doping process.
Yes, a bit like that. It's a little more complicated than normal glass because it's already has this color. So you need to
Yeah.
find one that looks good with this normal iron magnesium.
With that background color.
Yeah, so that's some of the research that we've been applying grants to innovate on.
Mhm.
So Made of Mars is trying to take this. This is all made from rocks on Earth for now.
Now,
while we understand
tell us
the
about
process.
what's in the bags.
Yeah, so these are kind of the intermediate step of these are Mars simulants. So this is just an example of taking the rocks we know on Mars and then trying to make it a bit better. So this is a very fine grain, and it's based on we've sent rovers to Mars. We know the chemical composition. So nothing on Earth is exactly like what we have on Mars.
Sure.
But there's a lot of things that are pretty close. So this is kind of created in a lab where we take something really close and we add the right combination of minerals and elements to create basically as close as we can possibly get to what we know on Mars.
Right.
And that creates something that we can build the technology we need. So this is sort of stuff.
Show them, you can hold that up a little bit. I mean, it's hard to see,
Yeah,
but
so
it's
just
a very fine
bag
powder.
full of fine powder there. You can make it any size you want, but it has the composition of, so like NASA spends a lot of money trying to create lunar simulants. These are simulants as they simulate the planets. So Mars and lunar simulants allow us to develop our technology. So before we go to Mars and start digging in the surface, before the astronauts went to the moon and started using their tools there, they practiced on as close to simulants as they can. So this is a way for us to take the intermediate step from knowing the materials on Earth, making it more like the planet, so that way when we eventually try to build things out of it, we know we're working with the right materials.
Right. Now, before you jump into some of the other products, back on the thread. So is the thread pulled from a liquid state?
Yes.
It is. So
Yes,
it's a little bit like making
lava.
fiber optic.
Yeah, but it's a lot more, a little bit more dirty than that because of the iron magnesium.
Sure. Yeah.
Yeah. So it's a bit of fiber optic nature.
But it's it is amazing how soft it is.
Yes. And that's because like if you think of like normal glass, even like fiberglass, it's rough and breaks and all that, and that's because it's high silica, and like silica is a glassy and it breaks. So if you have a volcano that's made of that kind of silica, it's like a Mount St. Helens that explodes.
Yes.
Whereas Hawaii, because it has really high iron content, it's allowed to flow. And so this is made from the iron side. So when you make your threads, you can have them flow out as these very fine threads rather than breaking them.
And they're not so brittle.
Yeah.
Cool. All right.
So that's why we're using basalt, and lucky for us, basalt's what we have in space.
Yeah.
It's really hard to find like pure glass in space. It's just a composition that's harder to find. Yeah. But on Mars, basalt's there. It's just one of the most common materials in our solar system.
Perfect. Okay.
So Made of Mars is trying to work on this whole, the vertical going for how do we know the materials on Mars? How do we find the most Mars-like stuff? How do we figure out how to turn it into threads and fabrics? And then we're also now launching some kind of products to put these into people's hands, so we can learn how to take these base materials and make something useful out of it. Like that's a whole nother step. How do we actually use it and make things that people want? So we're actually launching a Kickstarter now, making laptop cases and wallets. So this here is leather, which isn't a very good Mars analog, but sadly there's no basalt craftsman on Earth. So we went to a leather craftsman who worked with the basalts, made it attractive, figured out how to stabilize it pretty well, and then used what he had lying around to kind of finish up the rest of it.
So it's a hybrid with the basalt fabric. On what is their name? Have you named this fabric, by the way?
Basalt fabric is kind of the generic. We're hoping for lavaware.
Lavaware.
That's what I'm trying to figure out the trademark.
That's a nice ring to it. Hot stuff for you to wear. But okay, so this is made by stitching together leather components and then the lavaware.
Yep, and we're looking for more space-bound materials rather than leather as we go into the next generation. So this is just showing, getting these materials, these volcanoes into people's hands, and making sure we can make everything. So right now we're trying to figure out like what do people want, like how do we build the innovation cycles to build the stuff we want and learn how to make it well and learn how to make it better. As I mentioned, maybe you don't want a golden wallet, maybe you want a blue one or a green one or actually a red one. So how do we figure out the colors? How do we work on making the material stronger, more versatile? The idea is if we go to Mars, this is the main material we have. So it's great to have wallets, but it's not the most critical thing we need on Mars.
So how are you giving people the opportunity to get their hands on these prototypes of what may well be, the kind of products that are also made on Mars, but certainly right now they're made of the material that is abundant on Mars. So people can kind of
invest in this and
get an experience of what it's like, and maybe also offer some feedback on what you like or don't like, and things like that. Certainly it does have that softness. I understand also that fabrics made from this material are also fairly good in terms of things like fire retardant.
Yeah, this unless you throw it back in a volcano, it's not going to melt. So
it's not going to melt.
It goes up to 600 degrees Celsius without losing any of its mechanical properties. 1200 is when it starts to completely melt back again. So compared to other materials which melt in a few hundred degrees typically, it's much better than that. It's comparable to carbon fiber, a lot cheaper, but a bit heavier. So in places where you want that sort of properties but don't want to pay the carbon fiber premium, this has been used in that kind of world before.
So if you jump onto your barbecue pit with one of these wallets, You may not do so well, but the wallet will be fine, except for the leather.
As long as you keep it below that temperature.
Interesting.
Yeah,
Very
so
cool.
We're starting this process to understand, how to actually make everything we need. This is one of the graphics we have from our website, madeofmars.com. We're trying to build. We probably won't need wallets the first astronauts on space. Hopefully, they have. Don't really need money in the first few people.
Yeah.
But just they will need cases for protecting laptops, for protecting tools, all those things. Everything from the luggage they need to carry their gear to their spacesuits, their habitats. For instance, here's even a piece of rebar. This is all made from basalt,
Oh,
so it's
wow.
already being used in construction. These, if you look at the edge, that's just thousands and thousands of basalt fibers. It's a lot lighter than metal rebar,
Yeah.
and it's a lot less corrosive. So they're
Is it
already
stronger or is it
It's
similar?
pretty comparable to. It's within all the.
But now rebar bends.
Yes.
Does this bend?
This does not bend, so
Okay,
it does
so you have to
require.
kind of make it in the
Yeah,
shape.
so there's like end pieces that kind of help it connect. So it is a little bit more expensive on building, but especially in places that are humid, like Florida is using this a lot now because the humidity in that environment causes concrete metals to corrode.
Sure.
So that this is a lot less corrosive. It's just already rock. It can
Yeah.
sit out for millions of years without having
Nothing's
that
gonna
challenge.
happen. Nice.
So it is a little more expensive. That's why it's not as widely used as metal at this moment.
Yeah.
But where you normally need a forklift to carry a roll of metal rebar, this is like a lot lighter. So
Yeah.
a single person can carry a lot. So especially if we go to Mars and can start producing this there, it just opens up a whole lot of just even construction.
But it's interesting. It has a sound. It sounds like metal
Yeah,
or rock. That's interesting.
Yeah.
But it doesn't feel like it.
No.
It doesn't. It feels more like a plastic material.
Well, it does have a bit of resin on it just to keep it together.
Uh-huh.
So we've already started sketching out how do we turn Mars atmosphere into these type of chemicals to. So it's hoping to eventually make the whole cycle from what we have in space.
Right.
But it's just most compared to any other piece of rebar, this is much more made from Mars materials than anything else.
Cool. And now speaking, so if people are interested, this is your website,
Madeofmars.com.
madeofmars.com. So that's easy to remember. And you're raising some funds.
Yes,
now,
we're
is that
launching
right?
a Kickstarter. So if you want to bid on any of these products, so that way we can help get them into production.
Mhm.
The challenge is right now is there's no factory on Earth that knows how to work this material.
Yeah.
So we've worked with individual craftsmen, and so now we're raising money to actually take it to production
Okay.
and investigate how to do that.
So if you get enough orders of stuff, then you can
do
test that.
And we even
Okay.
have like a choose your own item sort of thing. So if even if you just donate $20, you can vote for the next item. So if you want something
Uh-huh.
to put a volcano in your pocket or whatever it is you want, keychain or suitcase or luggage, and you don't happen to need a wallet, you can help us produce something, and that will allow you to vote for what we actually make.
Yeah.
Because we the goal is to make everything.
Mhm.
Chances are you probably don't need to buy a spaceship these days or a spacesuit this moment,
Right,
but
right.
there's something that you may want made out of this material to help the cause along.
Mhm.
So we want to learn to make it versatile enough to make whatever we need.
Mhm. Now, for example, I assume with like a rubber bladder kind of interior thing, you could cover the outside of that
Mhm.
and almost have some sort of a habitat or
Yeah.
space that could, retain pressure and
Yep.
so on. I have to look and see what you got on the Kickstarter site, but I know, speaking of luggage,
Yeah.
even, like straps people
Yeah.
put around their luggage to identify it as their own, that would be kind of fun. Or, as we talked about, since the way this is already made, the kind of tie-down things that people have for their pickup trucks and
Yeah.
SUVs, et cetera, would be kind of fun and cool. But
Yeah, we like the fact that making it useful things.
Yeah.
We're not quite going into the jewelry market yet, because as nice as that is and it works well for that, we're trying to make things that will actually build the innovation towards what we'll need on another planet.
Sure. All right. Well, so and the baseball hat.
Yeah, that one's still in production. It's kind of showing how we're exploring with a lot of different ideas. This current material didn't really work in this well, so we're looking for
It's
innovative
interesting.
seamstresses who can figure out how to make this well. So this is sort of we've gone through many different project
So this is a
ideas.
much finer weave
Yeah.
than what you've done here.
Yeah.
So yeah, I can see some challenges. But these are the kind of problems you're
Yeah.
trying to solve, right?
Yep,
So,
and this shows an idea that we are playing around with many different projects.
Yeah.
And the ones that people want are the ones that we're going to put the resources to actually make.
What do you think?
So we do need to find the
Maybe
people
it's
who
not
are
me.
innovative enough to solve these problems. 'Cause
Yeah.
it is just a completely new medium,
Right.
and that's where a lot of challenges, but a lot of fun happens.
Yep. And so the Kickstarter is on Kickstarter
Yes.
itself. Okay.
Yep.
So they can find the Made of Mars.
Yep, search for Made of
Kickstarter.
Mars, and you'll find it, or go to our website and click on the We're on Kickstarter button, and that'll take you there.
Yeah.
So.
And so what's cool when you do that, you're helping develop the kind of technologies that, quite honestly, we have to develop, and now's a good time to start working on them, that are going to be needed for putting people on Mars and supporting them with materials, fabrics, clothing, cases, habitat, et cetera, et cetera, et cetera. So very cool. what about, so potentially as well, one could imagine even spacesuits being fabricated from this,
Yeah.
so you could have local production of
Whatever we need,
suits.
that's the hope.
I mean, you think about humans on Mars. Nobody's there for a 14-day mission like or a few-day mission like Apollo. You need to have suits which are robust, or you need to be able to make and repair them.
Ideally,
which
both
is
of them,
better.
right?
Yeah, right.
And especially,
Right.
the getting into space is the hardest part of everything.
Yeah.
So getting everything we need for people to survive is why getting humans to Mars is so hard. We need to, send 500 days of supplies, and humans are hard to keep alive.
Yeah.
So the more that we can make locally will just allow that exploration to happen much easier, much cheaper.
Yeah.
And so once we can have local production, it just will really unleash the future of space.
Cool. Do you have any other images here that you wanted to show, or anything?
This was the main one, just showing a beautiful pathway kind of idea of how we turn volcanoes into this future on Mars.
Yeah.
There's many more photos at the website, but I can let people explore their own space.
Oh, I see. You got the We're on Kickstarter thing. So
you can click on that.
Yeah,
Like I said,
yeah.
showing how we're trying to turn the rocks. Elon Musk is trying to get to Mars through an engineering way. He's an engineer. I'm
Yeah.
a geologist, so I'm trying to figure out how to use rocks to help get us to that. So this is the rock. And
I mean, it's
human
one thing
aspect.
to get there. It's another thing to be able to
Yeah.
stay there, right?
Yeah.
And have habitat resources necessary. Very cool.
I think we learned that in the moon, right? Like if you try hard enough, you can do these great things. But if you actually want to stay, it's just a whole new ballgame, right? Like that requires a lot more economics, a lot more drive, a lot more infrastructure to make that next step. And I think a lot of people, we want to get that first human to Mars, but then we just don't want to lose it, right? We want to keep that momentum going and build on from there. And this is a key part in that process to build on from that first ever human mission to Mars.
Right. Interesting. And have you started, I mean, it looks like now NASA's kind of back on the path of, well, if we're going to go to Mars, we got to go back to the moon first. It's going to be a great place to learn about the engineering and technological challenges and even societal, human behavior challenges that are going to be associated with long-term habitation in other worlds. You doing anything with lunar regolith kind of materials?
Again, the basalts are widespread, right?
So they're
as long
there
as
as
we're
well.
on the near side of the moon,
Yeah.
it's basalts everywhere.
Okay.
So this, I call it made of Mars because I'm a Mars geologist and I love the view of it.
Yeah.
But even if you just want to stay away from planets, as long as you're doing asteroid mining, there's plenty of basalt in that environment too. So you don't even need a planet to use the same technology.
Right.
So there's always the question of what do you want to call it? Made of Mars, made of moon, made of whatever, but basalt is just one of the most common materials that we've ever been able to find.
Yeah.
And so that's why learning to build from it is so important for wherever we go.
Yeah.
So yeah, it's just as useful on the moon as it is on Mars.
Sure. And it looks pretty versatile. I mean, it looks like an awful lot can be done with it.
Yeah.
And it's cool that you're in this beginning phase.
Mhm.
But anyway, so did we have some questions?
The only real question seems to be, when are human beings going to Mars?
Well, you want to opine on that?
Yeah, so it's not a matter of when, it's how much money do we actually spend on it? How much money do we invest in the rockets?
Right.
How much do we develop in the technology? And so for me, I've been working with NASA to help push some technology whenever they provide the money to help that happen. But it's frustrating. Every few years, NASA changes direction.
Yeah.
Even SpaceX, they're working hard. They have ambitious timelines, but they have a lot of technical challenges. And we're entering a new age of the new space economy where all these companies, us included, are trying new ways to develop this technologies. So when you ask when are we going to Mars, it's when you buy enough products for us to buy the rockets to go there,
Yeah.
right? So we're trying to put this in the crowdsourcing way, put this in the grassroots support. So if you're tired of waiting for SpaceX, for NASA to finally get us there, we want to put this journey into people's hands. So that way they can determine through communal support what the timeline is.
Sure. Well, and so JR made a really good point about the expense. And so, as much as anything, it's about our will to go there and our ability and will to spend the money necessary to develop the technologies and resources to do that. And I mean, you've probably heard me say this before if you've watched these programs, but in the Apollo program, which was essentially started with Kennedy's, we're going to the moon. At that time, so this is in the 1960s, NASA's budget was 4% of the overall total federal budget. It is now about 1/2 of 1%. So as a percentage of what the government spends money on, it's a very, very small budget. And but we do have now, we've got Elon Musk's and we've got a space economy developing and emerging. that has other interests in terms of space resource mining, et cetera.
It's
Could be
important to
helpful.
remember with the moon, we spent no money on the moon, right? There's no
That's
place
right.
to spend money.
We just went there and came back.
Spent money on jobs here, right?
Yeah.
So we were, employing people. We were creating technologies that would like help the entire economy. So for instance, here, I'm not putting any money on Mars. It's no economy there. So like we're building materials. So every time we build some type of basalt and we don't use cotton, that means we're saving cropland to grow food. If we use
True.
this instead of plastics, then we're not using petrochemicals.
That's
so there's
wonderful.
an incredible good sustainable economy here for using materials to take pressure off our currently overused materials. So less plastics, less natural fibers, things that will take less pressure off of our environment now. This is fully recyclable, it's renewable in volcanoes.
Yeah.
It's not the solution to the future on Earth, but it's definitely it could be a piece of the innovation we need to make life on Earth better. And
Well, I was going to say, it may be a
support
piece
this.
of
Yeah.
the solution to the problem on Earth,
And if we
which
ever get to asteroid
is
mining,
serious.
there's a lot of companies around here working on asteroid mining to
Right.
take materials from near-Earth asteroids and build from that.
Yeah.
And if we ever get that economy going, then that's a lot of materials that we can use for Earth or near-Earth uses that have no environmental impact here.
Yeah.
So there's a lot of, it's definitely futuristic, but it's getting close, and there's a lot of potential there.
Yeah. Well, in November, we have a mission landing on Mars, a NASA mission called InSight, and this is a very important mission. It's a lander, not a rover, but it's going to make incredible seismic measurements. It's going to be doing some drilling as well. And then Mars 2020 will be another Curiosity-like rover. It'll look a lot like Curiosity, but it has a hell of a lot more technology on it, a lot more advancements, and it has a mission to actually look for biology or science and evidence of biology. So that's coming up. And that's even going to have a drone on it, so it's going to actually have a little helicopter that's able to fly off ahead of the rover. But my own take, so people ask questions, you want a number. I would like to say that within the next 30 years, people will get to Mars. How long they'll stay on these initial missions, initial missions will probably be, go and return 6 months later or something like that.
One of the really exciting parts of Mars 2020 is they have an instrument called MOXIE, and it's designed to take oxygen out of the Mars atmosphere. There's not much, but it's like to test if you can.
Yeah.
And the idea, if that experiment works, if you can actually extract resources from the atmosphere, the next mission for this Mars 2020 plan is it's a sample return. So we want to go pick
That's
up
right.
samples to bring them back. And so the next mission will actually pick up the samples we're collecting now and launch it into orbit around Mars. We can pick it up later. But if this early MOXIE instrument works, the next one will have a much bigger scale and actually try to launch the rocket from Mars using the atmosphere on Mars.
Using it as its own fuel source.
So this will be the first time that we actually use Mars resources to help us explore it. And that's the secret, I think, to actually making exploration sustainable and self-propagating.
Sure.
We can use what's locally to take the next step.
Well, and if you've got water there, which you can break down into hydrogen, oxygen, you've got rocket fuel.
Plenty of
there as
water
well,
there.
and there's plenty of water there, as we know. So very cool. Any other questions come in? And do we have any folks share their point of reference as where they're watching us from? Lots of fun spots. So let's just say hi to some of them. So we've got West Virginia, Mountain View. I assume that's California.
No.
Oh, Mountain View, Arkansas. Okay, very cool. Spain, the United Kingdom, and Chile, Australia, Central Asia, Cologne in Germany, Budapest, and what does that one say? Connellsville, Pennsylvania, Charleston, South Carolina, Italy, and Buffalo, New York. So lots of friends from all over the planet. Very cool to have you here with us. And again, if you're interested in learning more about JR's program Made of Mars, check out his website. And if you want to have a little fun and help support the cause of developing future technologies for going to Mars, check out the Kickstarter campaign. And of course, there's always the ongoing SETI Institute campaign. So feel free to spread the love with the Institute here and help us continue to be able to bring these kinds of programs to you and this kind of outreach. So anyway, we wish you all the best with this.
Thank
We'll
you
be
so much.
looking and watching, and we'll probably hook up with you in a while and hear how things went.
Great.
But some very cool stuff. I'd love to have some of this
Try to
happen.
figure out how to put it into actual products.
Yeah, it's terrific, and the fiber is really interesting. Having been, much of my career in the optical fiber business, it's really interesting to see this. It's beautiful, very strong and soft. Yeah, pretty impressive. So we'll wish you luck with that.
Thank
Keep
you.
us posted,
I will.
and we'll check back with everybody. And we're going to be here again. You got another 2 for this week. You had 2 last week with Sophia. You got 2 this week. Because on Wednesday we're going to be with NASA heliophysicist Lika, who's going to be talking to us about the Parker Solar Probe. which is doing one of its orbits around Venus to help its ultimate acceleration around its solar orbits, which will ultimately bring it to the closest proximity to the surface of the sun than any other spacecraft ever launched by NASA or anybody else, and do incredible solar physics and data collection on the sun for us. So that's going to be Wednesday, and what time is that? 3
It's at
o'clock.
3, yeah.
3 o'clock in the afternoon Pacific time, Wednesday. So join us again for that, and do check out the website. Probably later this week and next week we'll be putting up some images and stories about the SOFIA experience and that incredible platform, the big 100-inch or 2.5-meter telescope on the back of that plane, and the science that gets done there, and the teachers who join us for that program. Very cool stuff. Thanks for joining us today, and thanks JR again.
Thank you all.
So from Mountain View, from me and Lee and Rebecca, so long for now, and we'll see you on Wednesday. Thanks for joining us.
Bye.